All right, this is the transformation part of the study guide. So these 10 questions were multiple choice. Which of the following, write a description of the rule x, y goes to is translated to x plus 10, y plus 8. So basically, our rule for translation was x, y, and then we had x plus a, y plus b. Okay. A was our horizontal shift, y was our vertical shift, or b was our vertical shift. So here we're going to go, again, positive 10, so that's 10 units to the right. So that's going to eliminate d and b. It's positive, so we're going to the right. And then y plus 8, so we're going up 8 units. So it's going to be choice A. This was our horizontal shift, this is our vertical shift. So we're going right 10, up 8. If it was minus 10, it'd be left 10. If it was minus 8, it'd be down 8. Okay, number 2 here, a point. -2, -10 is reflected over the x-axis, right? The coordinates of A prime. So a quick little sketch here. -2, -10 down here. We're reflecting over the x-axis, which is this one. So we're reflecting it up. So if we notice, our x value is going to stay the same. It's still going to be at -2, but instead of being -10, it's going to be up at positive 10. So it's still going to be -2, but it's going to be up at positive 10. Okay. Again, you think of how, another way is to think of how far away it is from the line of reflection. So if the x-axis is your line of reflection, it's 10 units below. It needs to go 10 units above. And 10 units above, it's still going to be at -2, 10. Okay, and the generic rule here was AB goes to, we can call it XY, goes to X, -Y. When you're flipping over the Y-axis, your Y value stays the same, but your X value is what changes. So point D is 2, 4. It's rotated 180 degrees about the origin. What is the coordinates of D? So our rule for 180 degree transformation was XY goes to -X, -Y. You're simply changing the signs on the points. So 2, +2, +4 is going to become -2, -4, which is choice C. Want to look at that on the graph. 2, 4 is here. Again, 180 degrees is going to be halfway around, so we go 90. Right, a 90-degree rotation, we switch the coordinates, so this was 2, 4. 90 degrees, we switch the coordinates, so it's going to become 4, 2. Okay, and you got to look at the quadrant, that's in the second quadrant, so that's going to be -4, 2. Then you go 90 again, you switch the quadrants back, the coordinates back, so it again becomes 2, 4, and this time it's in the third quadrant, so it's negative. So a 180 is just like doing 90 twice. But the general rule is you switch the signs, and that's it. It goes 180 degrees around, halfway around the coordinates. Halfway around the graph, I should say. Number 4, which of the following transformations does not result in a congruent figure? So we talked about 3 different rigid transformations. The rigid transformations were rotation, translation, and reflection. A rigid transformation meant that the size and shape of the figure stayed exactly the same. We just changed its orientation. We either reflected it, rotated, or translated it. We moved it around, changed its orientation, but we didn't change the size and shape. Then we learned in the unit after that congruent figures were figures that had the same size and shape. So we know those rigid transformations, the image and the pre-image were congruent figures because they had the same size and shape. We just simply rotated it, translated it, moved it, shifted it, and then reflection, we just flipped it. So the answer here has to be dilation. Okay, and again, the reason why it's dilation, right, if we dilate this, right, we might just end up making it larger. Okay, and obviously if it's not the same size and shape, it's not going to be congruent. If it's just the same size, just the same shape but different sizes, it's going to be similar but not congruent. So dilation is the one that does not result in a congruent figure. Number 5 here, we want to translate our figure 2 units to the left. So pretty easy, x, y, z. So let's go left 2. This becomes x prime, y prime, and z prime. We can connect them. I don't know where I'm headed here. Now coordinates there are -3, -1. 2, 4. And 0, -2. Why does it have 1, 4? 2, 4. Oh, I was looking at this one. There you go. Okay, shift 2 to the left. Number 6, if this triangle is reflected over the y-axis to form triangle H prime, J prime, K prime, what would the coordinates of the vertex K prime be? So we're reflecting over the y-axis. So we can use our rule here, x, y. We're flipping over the y-axis, which is the vertical, which means we're shifting it flipping it this way. So our x values stay the same. Our y values stay the same, and we have to change the signs on the x values. All the positive x's become negative, all the negatives become positive. The other way, and then we can plug each of the points in and use the formula, or we can count it out. So h is 3 to the right of the line of reflection, so we need to go 3 to the left. And that's going to be h prime. 6 to the right, so we need to go 6 to the left, that's j prime. K also is 6 to the right, so we need to go 6 to the left. And coordinates of k prime are going to be -6, +6. See. Reflecting over the y-axis, which is your vertical axis. So 6, 6 becomes -6, 6. Number 7, use the graph below. What is the rule for translation from point A to D? So here's point A, here's point D. We're going to go 4 to the right and 1 down. So we have our rule, x, y. We're going to go 4 to the right. So this is our horizontal shift, +4 because it's to the right. And then it's down 1, so that's going to be y minus 1. It's going to be A. A is your pre-image, D is your image. Translating 4 to the right, 1 down. Okay, CD, segment CD, was dilated around the origin by a scale factor of 2. The endpoints of the image are C prime 4, 0 and D prime 6, 2. What are the coordinates of the endpoints of the original line segment? Okay, so a scale factor of 2 from the origin. So the end result, so we had a line segment that ends up being 6, 2, 4, 0. Okay. So here is D prime, here is C prime. but it was dilated away from the center by a factor of 2. So if we want to go reverse, we're going to have to end up dividing by 2. So d prime was 6, 2. So d originally would have been half of that, 3, 1. Okay, C prime was 4, 0. So C originally would have been half of that, which is 2, 0. So here's our original line segment. It's been dilated away from the origin by twice. Every point on that segment is twice as far away. Right, so to work it backwards here, 3, 1. Again, dilation here, so our scale factor is 2. Our original points then are 3, 1, and 2, 0. And when we dilate them by a factor of 2, they're going to become 6, 2, and 4, 0. Okay, this problem's a little different because they gave us the end result and wanted us to work backwards. Usually when they have a scale factor, they give you the originals and say dilate it by a factor of 2. In this one, they gave us the end result and we had to work backwards to get the original points. Point x, -3, -2 is translated using the rule xy goes to x plus 3, y plus 4, and is then reflected over the x-axis. What is the coordinate of x double prime? So originally we have x, which is -3, -2. Okay, it's translated according to the rule. We're going to go 3 to the right and 4 down, 4 up. So -3, -2. That's going to be -3 plus 3, -2 plus 4. Okay, so that's going to give us x prime. It's going to be 0 and 2. So we take our point, we go 3 to the right, so that's going to put us at 0. We're at -2, we go up 4, that's going to put us at +2. Okay, we're then going to reflect over the x-axis. So again, the rule for reflecting over the x-axis was xy goes to x stays the same, and your y value changes sign. So here, x double prime is going to be 0, -2, which is choice B. Right, so again, if you want to look at a graph, 0, 2 is here. This is the x-axis, so we're reflecting down. This is the y. We're going to reflect down. Right, it's 2 units above, we're going to go 2 below as we reflect over the x-axis. So 0, -2. And then number 10 here, a rectangle is plotted on the coordinates plane below, which image shows a 90 degrees clockwise rotation about the origin. So let's do the rotation up here and then we'll check and see which answer matches that. So I'm going to write the points off on the side. We have 0, 0. We have 0, 2. We have 6, 0. And we have 6, 2. We want to go 90 degrees clockwise. So that's this way. Okay. First thing for 90-degree rotation, we're going to flip the coordinates. And then we got to figure out the signs. 2, 6. Okay, so step 1 was to flip the coordinates. Step 2 is to figure out the signs. So 0, 0 is on the origin. That's what's being rotated around. So 0, 0 is going to stay 0, 0. Okay, 2 zeros up here. I'm sorry, 0, 2 is up here. Okay, we're going to go 90 degrees, which is going to go from the y-axis to the x-axis. And that's going to be a positive 2, 0. 6, 0 is on the x-axis here. We're going to go 90 degrees. So it's going to end up being here at -6, 0. Or sorry, 0, -6. 6, 2 is up here. Quadrant 1, it's going to rotate 90 degrees. So it's going to end up right here. Okay, the coordinates or the signs for this quadrant, for quadrant 4, are positive, negative. So it's going to be positive 2, negative 6. And our 90-degree rotation should look something like this. Okay, and as a reminder, the board stretches the image so it doesn't look like it's equal, but it's because the squares are stretched. It's just the way the projector is. And it's a 90 degrees clockwise rotation, so that's going to match up with answer choice A here. And that is the transformations part of the review.